Okay, 13.4, sine function. We did the amplitude, right? What's the formula for amplitude? That's right. It's the max minus the min divided by 2. And what's the midline? Midline was the max plus min divided by 2. I'm going to use K for now for the midline. Okay? Okay. Our equation here, we're going to be working with the parent function, y equals the sine of theta. I don't know if you can read that too well. Okay? Shh. 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 Little Jesus, stop. What is it?
Slim Jesus.
Flynn or
Slim?
Slim Jesus?
Slim. You want to hear his famous song?
All right. No. This is your basic parent sine function. It starts at 0, goes up to 1. That's our max. Distance from the midline to the highest peak or lowest valley. That's our amplitude. Okay. From 0 goes up to 1, goes back down to 0, goes to our min, -1, goes back up to 0. Okay, this is 2 pi. That's our parent function of sine. Okay, blank is the time it takes to complete one pattern. Time, period. And we discussed this before in 13.1, right? We went through the vocabulary. Oh, this is the sine function itself. All this other stuff, this vocabulary, is from 13.1, which some of you were talking and not paying attention, so you probably have no idea what I'm talking about right now. It's working so far. We'll see how long it lasts. All right. We're going to take our little formula a step farther. We're going to use the y equals a sine of bx. And we have some definitions for the new variables that I put in there. Now, for the rest of this course, actually, there's a k over here. For the rest of this course, including trig modeling, which is fun, you will be figuring out what the amplitude is, what the period is, and what k is. Okay, k is a vertical stretch. But for now, we're not going to worry about vertical stretch for a couple days. We're going to worry. Why are you guys being such a douche? Will you take notes and pay attention? Both of you. What? Well, they are. They're being a big douche. So, oh, you want me to sugarcoat it? Oh, will you guys stop? Stop and please pay attention. Quit being a douche. Pick up a pen or pencil and take notes. Here. Okay, the amplitude. Shh. 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 Yes. I'm not ready to retire, but I'm not going to coddle you guys. How old are you guys? You're like 18 years old. 16. Do you need somebody to tell you to get up and get a pencil? Come on. You're driving a 4-ton vehicle. That's very responsible. You can at least get a pencil.
He doesn't have a car.
And you wonder why I call you guys douche.
I'm a dumbass.
What? What do you want, Slim Jesus? All right, let's get back to this. Shh. Your parents must be really proud of you guys.
Yes, they are.
All right, A is our amplitude. Remember, shh, shh, shh. Amplitude is a distance, so what does it have to be? What does a distance have to be? Guys, quiet. What is it? It's got to be a positive number, right? This has to be positive. So, shh. Because it's distance. So what we do for the amplitude is we take the absolute value of it. Now, it doesn't mean our sine function can't have a negative a here. What happens when I have a negative sign out in front of any function? What happens when I have a negative sign out in front of any function? How about a parabola? What happens if I have a negative sign in front of the x squared? It flips. Who said that? Okay, it flips. Okay, shh, 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 shut up. So if I have negative sine of theta or x, instead of it going, it still starts at 0, but if I have that negative sign, it's going to reflect, so it's going to go to our negative, and then positive. Okay? Our regular sine of theta or x, it starts at 0, goes to our max, then min. Do you see the difference? Negative function, but the amplitude, okay, the amplitude is still positive because it's a distance. Shh. All right, the period, we talked about the period, equals 2 pi over b. And b is the coefficient of x, or, guys, I'll tell you right now, I'm so used to putting theta there. I think all of the problems use x from here on out. I'm sorry if I use theta. I don't mean to confuse you. It's just I've been using theta for 40 years. Okay. Yes. All right. Example. What is the period of each sine function? So the period equals 2 pi over b. What's our b equal here? That's right, 8. So this equals pi over 4. That's the period. Well, what does the period mean again? If I was to graph this, and we will graph this in a minute, that means my period, it ends at pi over 4. So somehow I'm going to have to fit that sine function in that period. Okay? We're going to be doing this in about 5 minutes. Okay, B, what's our period? It's going to be 2 pi, and what's my B? It's 1/3. So 2 pi divided by 1/3. Now, shh. What happens when I divide by fractions? That's right. I flip it and multiply by its reciprocal. So this is 6 pi over 1, or just 6 pi, right? With me? Okay, what's the amplitude? This is easy. What's the amplitude of 2a? What's the amplitude of 2a? 2. That was hard. What's the amplitude of b? Thank you. It's the absolute value of a, which is 4. Okay, don't freak out. We're going to find two things at once. Wait. Okay, we have to find the amplitude at the period. What's the amplitude? What's period? Well, it's 2 pi over b. What's my b? So I get pi over 2. That was hard. What's my amplitude? 1/2. What's my period? 2 pi over b. What's my b? 1/2. I have a number divided by a fraction, so I have to flip it and multiply it. So I have 4 pi. C. What's my amplitude? It's the absolute value of a, which is 3. My period? 2 pi over, what's my b? So I just have pi. Easy, right? Okay, this is how we're going to graph these sine functions. Did you even pick up a note sheet? Do you know, like, about 25% of your final next Wednesday is this stuff? Okay. You frickin' doorknob. Alright. Well, you guys are idiots. I don't understand it. You're not taking notes just because it's like 2 weeks of school left. You've been done since January 1st.
I've been done since the first day of school.
Alright, so this is how we're going to graph a sine function. Number one, we're going to find the period and create a scale for the x-axis. Again, this is my x-axis. This is my y-axis. Okay? Step two, we're going to find the amplitude and create a scale for the y-axis. Step three, we're going to plot 5 points. 5. I guess it is 5 points. And then we're going to connect it with a smooth curve. We're not going to use V's. We're going to use smooth curves. Okay. Example. Graph y equals 2. Sine quarter x. Okay. Find the period and create a scale for the x-axis. Step 1. What's period? 2 pi. What's my b? Shh. What's my b? 1/4. So 2 pi times 4 is 8 pi. Okay. 2 pi over 1/4. Yep. 1/4. Is this fuzzy or is it me? It's fuzzy. Alright, so my last point here, where my sine function ends for this particular function, is 8 pi. Now, there's all different kinds of ways to scale this. This first year I was with Mrs. Abruzzo, and she did a pretty good job. She did it a different way. She's like, Well, we know we're going to have to put in 1, 2, 3, 4 points, right? So the way she taught, because the sine function has a 0, a max, 0, min, ends at 0. Okay? So, who's talking? Stop it. Stop it, Slim Jesus. Okay, so what she did to find the first quarter point, right? These are quarters. What she did to find the first quarter point was pretty slick. She took 8 pi divided by 4. Okay? What's 8 pi divided by 4? That's right, 2 pi. So she said this first point is 2 pi. Okay. Now, think about this. You got to use your brains a little bit. To get from here to here, it's 2 pi. To get from here to here is what? Another 2 pi, which is 4 pi. To get from here to here is, and she got her 4 points. Now, this is going to get a little more difficult when we get into fractions, but we'll get there. All right, now, step 2. Find the amplitude. What's the amplitude here in our problem? 2. Okay, so I'm going to go from 0. I'm going to go to 2. Don't forget to go to 2 the other way. -1, -2. Sine function starts at 0. Let me use green. Starts at 0. Okay, goes to the max. Do you guys see it? See it up here? Starts at 0, goes to our max. So the next point goes to the max at 2. Then the next point goes back down to 0. Okay, then it goes to the min. So the next point is the min at -2. Then it goes back up to 0. Okay. Then it goes back up to 0. Now, this is where you're going to use your smooth curves. Okay. I don't want to see, I don't want to see this. Now, you're going to start at 0. I don't want to see that. That's not the sine function. You have to use smooth curves. Is it really that bad being quiet? Look at you. You're about to bust.
Bro, you got it, bud.
Watch how you word this to me.
Huh?
Watch how you word it.
If you got it, bud, you got it.
Oh, jeez, I forgot you guys are high. I keep forgetting you guys are high school kids. All right. Let's see. I want to give you guys time to do your quizzes. Let's do one practice problem. Let's focus on the back of this thing. Shh. All right, let's do let's do a harder one. Let's do number 21. Okay, 21. Shh. I'm going to sketch the graph. So I need my y-axis. Shh. Need my x-axis. I don't want to move everything because then the cord will mess up. All right, step 1. Find the period. 2 pi. What's my b? What's my b? What's my b? 3. 2 pi over 3. So that's where it ends. 2 pi over 3. Okay. Now, we have to find our quarter points. This is what I mean where it gets a little hard. Quarter point. I'm going to take my period, 2 pi over 3, and I'm going to divide it by 4. All right, that's 4 over 1. So I'm going to take 2 pi over 3 and multiply it by the reciprocal, which is 1 over 4. With me?
Yes.
So I have 2 pi over 12, which reduces to pi over 6, right? So that's my quarter point. Okay, my quarter point here is pi over 6. Now, instead of getting all confused and trying to simplify these while you're putting them in there, let's just put them in there and then simplify them later. Okay? Each quarter point is pi over 6. If this is 1 pi over 6, what's this? 2 pi over 6. What's this? 3 pi over 6. Okay? Now let's reduce them. So 2 pi over 6 is pi over 3. So we're going to replace that with pi over 3. 3 pi over 6 is 1/2 pi, right? So pi over 2. So we're going to replace that with pi over 2. Now, on a test or a quiz, if you don't reduce those, I got to take a point off. Okay? It's an important part about graphing trig functions. Okay, next thing. I wish I had a different color pen. We need the amplitude. What's our amplitude here in our equation? 5. Okay, it's the absolute value of -5, which is 5. Okay, so from 0, we're going to go up to +5, and we're going to go down to -5. So there's our y scale. Be careful here. We do have a negative sign in front of our function, right? So sine function always starts at 0. Instead of going to our max, we go to our min first, right? So here's our quarter point. We're going to go to our min. Here's our next quarter point. We're going to go back up to 0. Our next quarter point, max. Then we're going to go back up to 0. Smooth. And there's our whole problem. It's not too bad. You do have to do some practice. Do make sure you do at least 19, 20, 22. And if you can, do some on the other side for homework. Well, you do have to go at every dot. This dot is our min. This dot is 0. This dot is our max. So you are hitting every dot. Good question. All right, I want to make sure you guys get some time for your quiz.